So the purpose of this video is to show you the procedure of writing a simple Java program, because once you write simple, you can always get it more complicated. So let's close everything and start it all from fresh. In fact, let me close everything here so I have more screen space. All of this stuff is in your Dropbox if you want to review it before next week. By the way, the quiz is going to be really simple. The quiz is not going to be going to a lot of levels of complexity, right? So don't be stressed about that. But, all right. So step one is we open our command prompt. So you're going to open your command prompt using either bash on Mac or command on Windows. And then you're going to find a directory to save your work in. So I'm going to make a directory here, mkdir, and this is all based on Unix. So Mac OS and Windows OS, exactly the same. It's all been the same since 1960 when the Unix operating system was written. mkdir, and I'll go by today's date, which is the 13th of September. So I'll say 2021-09-13, and I'll cd into that directory, change directory. And that's it. Now I have an empty directory. Now I go and open my favorite text editor, which in case you haven't already figured it out is Sublime. I love Sublime. I think it's nice. And by the way, you guys should know that whatever I teach you, I study job ads and I see what employers are asking for. So whatever I'm presenting here in class is what I see employers asking for. So now I'm going to make a simple program. So I'll say file, actually I already have a new file. So public class, and I'll call it peanut2 because why not? And you can go and review my mind map, right, or of course visual learning roadmap. Oops, where's my curly brackets? Oh yeah, it's there. So always start by saving, so if it locks up, you won't lose your work. And the Java rules say that we have to have one public class in our file, and we have to name our file according to whatever that public class is called. So say File, Save As, and go to your directory now. I forget what I called it. Yeah, Java Learning and then the date. So Java Learning. And now I go into that directory and I call it peanut.java and I lint it as a Java file. And there I've got my linting. Now remember, Gosling said that we have to have one main method, and that's like kicking the soccer ball. Whatever's in your main method is where things get started. So public, static, void, we'll explain this in a little bit, main, string, is there a data type? Now this string needs to be an array, and your variable name has to be called args, exactly that name. If you don't believe me, try naming it somewhere else. You'll get a compile error. And once again, we give our implementation there. And now we say save. How much more time do I have? 20 minutes roughly? I will be okay. And now I'm just going to give a simple output message. So I'll say system.out.println. Just hello for right now. Every line must be terminated with a semicolon. You know what to do after this. I think you know already. So we'll say save. And double check that I'm actually in the right directory. Make sure my program file has been saved properly. There it is. Now what do I do next? I hope you said I do Java C, Java compile. So Java C, peanut2.java. So now I compile. No errors, yay. And now my class file is there, right? So you can go and study that in the PowerPoint. So the result of doing that is I now generated this hexadecimal file, which I can now pass as the parameter, that file name, to my Java runtime. Yay, we're doing good. So Java, you can put java.exe, have it or don't have it, either way is acceptable. And now I say peanut 2. Oh, well, once again, see, I made the same mistake that I made last time. I don't know why I keep doing this, but that has to be lowercase. Oops, main. So save. Compile again. Hello. Yay. All right, so that is a simple program, but let's amp it up a little bit now. Now, the way things here work in programming land in object-oriented, and I'll talk about the philosophy of object-oriented next week. In fact, we have a bunch of stuff to talk about next week. Let's make sure, let's write a little list so we don't forget about it. Mostly this list is for me because you guys don't forget. I'm the one who'll probably forget. So let's say now for our September 20th class, so September 20th class plan, we're going to talk about the details of, we're going to lecture and we're going to draw some whiteboard and some pictures. Von Neumann architecture. How data is encoded and stored and manipulated in a computational system. And we're going to talk about something called unified process as a way of designing, like where do we get all these objects from exactly? Where do they come from? How do we design our application? So we're going to talk about unified process. And if you want to get a little pre-read on that, I'll share a video with you. You can watch to warm up your brain cells in advance. And that video is available right here. It's probably on YouTube, but I just want to save some time. I'll give you the link to my Dropbox. Do Mac users, I think Bash, isn't Bash built into Mac? I think it is. Bash is just your terminal in Mac, I thought. Bash is the default command prompt in Mac. Or what you can do for Mac users, just hold the control, the space bar. And while you're holding it down, type the control key and you'll get your spotlight, your little box to type things into. That's called the spotlight box. And then just type terminal and then just whatever terminal is there, use it. Use whatever terminal is there. Is default for your system. Yeah. And again, you could just go on YouTube and say, write a simple Java program on Mac and just see what it shows you. All right, where, oh yeah, I was sharing with you some stuff on unified process. Unified process is our design methodology for object-oriented programming. And you can watch especially, just watch this video. I had a student who called me at the end of last term, and she was screaming so loud I thought she was going to break the speaker in my phone. I said, Ramanjeet, cool down. Are you okay? What's happening? She had been to a co-op job interview, and the interviewer asked her, he said, if we put you in charge of designing a software application, how would you do that? And I was an interviewer at IBM for co-op and internship students. I was trained that we were supposed to ask questions to cause the students to be stressed because we want to see how they handle pressure. So I think that's what the interviewer was asking, because that's not really a reasonable question for an entry-level job. But she said, Peter, I said everything you told me to say in that video, and the interviewer was so shocked that I knew all that stuff. She said I thought he was going to fall down. I'd have to call 911. He's having a heart attack or something. So anyway, this stuff works, right? This is like an ATM. This is what's going to get you your job. So for next week, read all the stuff in here. Just, you won't probably totally understand every drop of it, but just get started on it. So read this material. And at least watch this video. If you do nothing else between now and next week, watch this video. Your quick intro to unified process for the job interview. Yay. So next week, von Neumann, how data is stored, the basic construction of the basic Java program. And that'll be enough. And then we'll maybe go into some stuff with database. We'll see how we do for time. So now let's go back over to here. So now we got our simple program running, right? We did that. We got it to output hello. So now let's talk a little bit about the construction or the basic programming elements of Java or any programming language. Because the concept here is a programming language really only has two things. When you think about it, that's all it has. It's not hard. Where's my PowerPoint? Did I close it? Maybe I closed it. All right, let's open it again. And in fact, everything we're saying now is equally applicable to every programming language anywhere in the world, except quantum computing. That's something else, but we're not talking about it. But if it's any classical von Neumann architecture program, here's how it goes. So we have data stored as data attributes or data fields in the class. And we have methods. That's what makes the program do stuff. That's the code that makes the program do stuff. So everything in a Java program must be stored in a method. You can't have stuff floating around in a class outside of a method. So let's see about that now. So let's go and extend our simple program a bit with our remaining 10 minutes of time. 10 minutes exactly, okay. So here, I'm going to write another class now, and I cannot call it public. If I call it public, I will get a compile error, but so I'm not going to do that. I'm going to say class calculator. Calculator. This is kind of a typical standard first example of programming language. And I'm going to give my calculator, what does a calculator do? Well, it adds. So I'll say public add. That's my add method, and I'll give it some input parameters, int A and int B. And I'm not explaining it because we only have 10 minutes. I'm just going to show you, but you can always read my visual learning roadmap as well. Oh, by the way, there's another very nice textbook we have. They give you a textbook in the course outline, which is great. Well, it's expensive. It's about $80. But Peter has a very nice textbook called Learn Java the Hard Way. And because I'm a nice guy and I care about you, I'm going to share that with you. Now I can't remember which directory it's in, so I have to go and search for it. Hang on. So let me go to my Dropbox. Dropbox. I don't know how teachers in the old days managed it. I really don't. Like, I counted all of these things so much. So Java the hard way. Java the hard way. Learn Java. Oh, it's in my, oh, I see where it is. Okay, hang on. I'm going to share that with you now. And it's a great textbook. It's amazing. It's not as good as the book I'm going to write, of course, because I have a big ego, so I have to imagine that I'm always the best. But for something written by somebody beside me, it's pretty good. So Academic Desk Instructional Material, Java, PDF books. Java. Actually, I'm going to share the whole thing with you. Why not? So you can read all of that stuff, but at least, actually, and I'm going to share your resource on this Learn Java the Hard Way. I'm going to share that in your Moodle page because that's something I want to keep your attention on. So copy Dropbox link, Learn Java the Hard Way. So everything I'm saying, if you want to study a bit more on it before next week, just jump into there. They do a very nice job of handling this. And we have another 5 minutes. All right, so let's use our time here. So I'm going to make an add method. So I'll say public, and whether it's public, private, protected, or main, we'll get to that next week. But public, and I want to return something of data type int. So our method signature must have a return type, a name, and a signature, which is the parameters and the data types of the parameters. I'm going fast. Well, we'll come back to it. This is just a preview. Now I'm going to give a method implementation, and I'll say I want my method to return a plus b. So I've written a little calculator that can add two numbers. Probably won't win any Nobel Prizes, but it illustrates the concept. Now, how do I use that add method? Well, up here in my main method, because everything always starts in the main method of the public class. Everything always starts in the main method of the public class. So here we're going to say calculator. See, that's a data type we made by ourselves. Give it some reference name equals new calculator. That's a constructor. We'll talk about constructors later. And now we're going to call the method. We're going to say C. So we're going to use dot notation to reference the add method. And we're going to give it some numbers. And now we need to get the output from that, don't we? So it's returning the addition. So here we can say system.out.println. And let's try running this and see what happens. So I'm going to say save. And we have to go back and recompile. So go back to your command window. There it is. So we'll say Java C. No error messages. Now we'll run. 4. So guys, later on today when you talk to your friends or classmates or whatever, and they say, so, what did you learn at your fancy college today? You can say, well, they taught us that 2 plus 2 is equal to 4. Now, it would probably be good to extend this. What would happen if we could set it up so we could pass in different numbers each time it runs? So here we're getting a command line argument. So whatever things we put at the command line, it can take them and process them. So instead of hard coding those values in, let's say args, and we access array values with the square bracket notation. Yeah, I know I'm going super fast right now, but we'll get back to it. So I want to say whatever I passed in as my first argument plus, well, actually that should, yeah, 0th is first because it's 0 based, plus args 1. Is that going to work? Well, I hope so. Let's say save. So now every time we run the program, we can pass in some numbers on the command line and it should add them up for us. Let's find out. So save, compile. No, I got an error on line 6. I forgot to put a closing round bracket. So there's line 6. So I opened and yeah, see, because I need a round bracket for my add method, but I need another round bracket to close off that. So let's put that there. And if I was doing this in Eclipse, Eclipse would catch all of this for me, but it's good now I have to use my own brain, which is the best computer ever invented. Let's try again. Compile. Oh, actual and formal parameter lists differ in length. They do they? So there is my formal parameter, and here's my actual. So I messed up on my brackets. Why did I do that? That should be okay. So c.add, I don't know why this is wrong. This should work. Well, there's another thing we can do here. Okay, let's break this up a little bit. Guys, I think it's 12 o'clock. If you need to leave, class is over, leave. I'm just going to take another 2 minutes to fix this, and then I'm going to kick out this video. It'll be in your announcements later on. So if you have another class you need to go, go. But if you want to stay and hang around with me, that's good too. So we'll say int a, we'll call it input 1 equals this. Now, I'm not sure about the color coding there because I should not be seeing a difference on that color coding, but I don't know about that. So copy and paste. So we'll say input 2 equals now the first, right? Because zero-based indexing, just like in Python. So now I should say add. And see, my Sublime is giving me some color coding on my semicolon. It's reminding me that I forgot my second round bracket. So that's better. Now I can say input 1 plus input 2. Let's try that. And again, I'm not sure what's going on with that color coding. That seems that it should not be doing that. Anyway, save, compile. Oh. All right, guys, what's going to happen right now is it's 12 o'clock. I'm going to end the class, but I'm going to spend a couple of minutes by myself right now, and I'm going to fix this up, and I'm going to kick this video out, and then if you want to watch the video, or else we will we'll finish this next week, right? So class dismissed. You're free to leave, but if you want to stay and hang around with me for a couple of minutes, you can do that too. So class dismissed. Keep your eye on your announcements for this video. But I'm still going to stay with this for a couple of minutes. And you're welcome to stay with me if you'd like. Either way, you can do it either way. You need a comma instead of a plus. Oh, yeah, maybe because I'm doing this under a little time rush. Maybe I'm... Oh, yes, of course. Of course. Thank you. That's right. I missed that. That has to be separated by a comma. Thank you. That's why I was... Okay, amazing. That's great. Thank you. Very good. Thanks, whoever caught me on that. Thank you, because because when you do things under a time pressure, things like this happen. Thank you, Gunny. You were great. You got that. Yep. Probably everybody else got it too, I think. So let's try. So what it was saying now is my formal parameter list was 2 parameters, but when I put a plus, it was treating that like 1 parameter. That was the error message that said your formal parameter list doesn't agree with your actual parameter list. Yeah. All right, let's try again. Compile. String. Yeah, now here the thing is that what I get from the command line is text, right? We're going to talk about data types next week, but it needs to see a number. So we have to convert text to number. So the way we do that here is shoot, how do you convert? Because I teach 4 different languages this term, so I just want to see if I can drag this out of my brain. Integer, I'm not sure if I'm going to get this right, but I'll try. To int, is that it? If I can't, I'll go and Google the code, but I think that's the right, just a second, hang on. Java convert string to integer. It's in your book, by the way, as well, Java the Hard Way. String. I'm not sure if you're remembering, if you're understanding the problem, but what comes in from the command line is a string, but the addition requires an int or a double or a float. Oh, parse int, that's it. So I say parse int, integer.parseInt. So integer is a class in the JDK, and it has a method called parseInt, and that should convert it to an int. So parseInt. Okay, let's give that a shot. So save. Yeah, that should be ready to go. Let's try. Now I have to give some numbers here, right? So now I'll say 3 and 3. And the value is 6. So yeah, that's gotten. Now I'm going to save this in my GitHub, and I'm going to share my GitHub with you each week. So let's take a couple of seconds to do that if you want to play with that. So the main factor here is we've now created another class, and we're calling the class from our public static void main by creating an object reference and then calling a method on that. And that is the first step towards constructing real-world complexity Java applications. So we'll say save, and I'll share. If you need to go, that's fine, right? Class is over, but if you stay with me and keep me company so I'm not lonely, that's nice too. So GitHub, and my GitHub is with Professor Brown Bear, my avatar. It's called Computational Knowledge. I know you're going to say, Peter, you're an adult. You're not really supposed to like cartoon animals. Well, my answer is I like the line characters. Deal with it. So here we're going to say repositories, and we'll make a repository for our class, which is new, and we'll call it Java Programming. '21 fall. All right, yay. And I'll make it by date, I guess. So September 13th work. So make a new file. Call it September 13th. Make one for each week. September 13th. Yeah, so you can grab that and play around with it if you like. So I'll put a link to this in your Moodle. So we'll say course GitHub repository, which is where I'm going to store all the code for everything we develop. Course GitHub repository. What else do I have to say? I think that's about it. Well, there's tons of stuff we could do. Sadly, we're out of time, so class is dismissed. and we will carry on our investigation.